Good evening, class. Can you hear me?
Yes, teacher.
All right. Okay, class. Let's start today's sessions. Have you reviewed last week material? No, not really. Folk, don't forget to review class material. Otherwise, you're gonna start from zero again. All right, class. Last week we discussed the first part of the inference on multiple regression analysis. So mainly last week we discussed how to do hypothesis testings by looking at t-statistics. You learn that for one-sided greater than 0 to reject null hypothesis, t must be higher than critical value. And in order to find critical value, you need to know degree of freedom, and you have to select your significant level. And how to generate t-statistic? It is coefficient minus hypothesized value. But if hypothesized value equals 0, it's minus 0 divided by standard error. And again, to compute t, it is coefficient minus hypothesized value, but most of the time, null hypothesis state delta equals 0. So that is become t equal coefficient minus standard error. To find critical value, you need degree of freedom and you need significant level. And then we have to look at the critical value for t distributions. All right. For one-sided alternative hypothesis testing greater than 0, t must be higher than 6. For one-sided alternative that is less than 0, t must be lower than minus 6. For two-sided, however, absolute value of t must be higher than 6. All right. So the way you obtain critical value from t table, from t distribution table, it also depends if you choose one tail or two tail. And from last week, I informed you that to make life easier, use two tail. All right. And if you use two tail, if you have light in that sample, we have some general rule from last week. Significant at 10%, 5%, and 1%, what is the t or critical value? Again, what is null hypothesis mean? Null hypothesis, say delta equals 0, mean that there is no effect of your independent variable on dependent variable. Or they believe that the true population has no effect at all. So you have to create an alternative, probably bigger than 0, less than 0, or most of the case different from 0. If it is different from 0, you use two-sided t-test, right? And from last week class, you learned that if t, for instance, higher than critical value, then you probably need to reduce your significant level. You want to know if the significant level is if it is only significant at 5%, you may go down to 1% if it's still significant. So you know, it is not practical to look at critical value because you often not do it one time, but probably multiple times. If it is significant at 5%, you have to look to move the significant down to 1% and check it again. However, if for instance 5% is not significant, and then you try to adjust it to 10%. So as I informed you, that is not really practical. Today, we're gonna continue from T-6 to compute p-value. All right. If we use p-value to test our hypothesis, we don't have to memorize. We don't have to look at t-table to find critical value. All right. So now let's move on to today's session, which is the multiple regression analysis inference. By the way, let me remind you, so far we're still discussing multiple regression analysis. Both dependent and independent variables are numerical or quantitative information, not qualitative. And our data is cross-sectional. All right, we're still now on cross-sectional data. Both independent and dependent variables are numerical, interval, or continuous. All right. So now let's continue our discussion. So today we discuss 3 different cases on hypothesis testing using one-sided, two-sided. Right. So now let's discuss more about p-value for t-test. As I just recap, when you found that t is lower than t is bigger than c, or you found that t is bigger than c, then you start to lowering down your significant level. You want to know what is the smallest significant level which null hypothesis would be rejected. If it is rejected at 5%, you may want to check if it is rejected at 1%. Right? And that smallest significant level in which null hypothesis is still rejected, it is called p-value of hypothesis tested. Right? That is called p-value, the lowest one, the significant lowest one. That probability is actually, we call it p-value, the probability value. A small p-value is an evident against null hypothesis because one would reject null hypothesis even small significant level. You will see next, but what it is saying here is that if you find p-value, for instance, 0.6, 0.06, and if your significant level is 0.05, then you can just compare the p-value with your significant level, let's say alpha. All right. So you can simply compare p-value with significant level that you selected. So you don't have to find critical value. If, for instance, you found p-value is 6%, so you say that null hypothesis is not rejected at 5%, but it is rejected at 10%. So you compare directly with the significant value. All right. So normally a large p-value is evident favor null hypothesis. So if the p-value is high, we fail to reject null hypothesis. So normally, class, when you have to look at the p-value is normally computed for two-sided test. And most pancakes like as data that we are using in this course, it also computed from two-sided test. All right, from two-sided. P-value is used for two-sided. Right? So p-value is the significant level at which one is indifferent between rejected and not rejected null hypothesis. We want to know the probability that is rejected from your null hypothesis. Now, in example where we have degree of freedom equal 40, t equal 180, so we want to know probability that t is higher than 1.85. So in this case, for instance, we obtain p-value equals 0.718. So don't worry, p-value, the standard pancake will compute it for you. Here we do not look at the math, all right? Normally standard pancakes like as data will compute it for you. We will go to the hand-on exercise after this lecture. All right, but here how do we interpret this p-value? Right? We found p-value equals 0.0780, which basically about 7%, right? If you convert it to 7%. How do you interpret this? Normally, I'm not quite sure if I informed you last week. The three significant level that is often used is 1%, 5%, and 10%. All right? Meaning that if 10%, you allow it to be error at 10%. All right? So here, you found p-value is 0.7, which exactly 7%, right? Let me find my pen. Because this one is actually 7%. So simply when you obtain p-value, you just compare with this significant level. Here, 7 and 1, which one is bigger? Oh, 7 is bigger than 1%. Then you say, all right, null hypothesis is rejected at 1% because p-value is high. At 5%, p-value is also rejected at 5%. But at 10%, no. We fail to reject null hypothesis at 10% because p-value is 7%. What it says here is that if you conduct it, if you want the error 10 times, but here the error is only 7 times, which is under your acceptance rate. You only allow for error to have 10 times, but here the error is only 7 times. So it is below your acceptance level, below your significant level. Here you allow for only 1% error, but here we have 7% error, so you cannot accept it. Here you have 5% error, but the actual error is 7%, you cannot accept it. But if you allow for error at 10% and the actual error is 7%, it is acceptable. So I try to use a simple explanation what that really means, right? So if you obtain p-value, it's very straightforward. Just compare it with your significant level. And again, theta will compute that for you. We will move on to theta. Following me with the interpretation of the p-value?
Sure. So p-value is the error percentage, right, sir?
No. That is we call probability. Probability that no hypothesis that may happen.
Okay.
So what we say here is that actually beta 0 may be equal 0, but that can be happen among only 7%.
Yes, sir.
But when I say error here is that normally we are interested to look at significant effect, right? So if we reject null hypothesis, meaning that if it is 7%, meaning that we will find that beta 0 may equal 0 with this 7%, but 93% beta, our null hypothesis, may be different from 0. That's what it means. All right, again, this 7% meaning that it is the probability that your beta is equal 0. So you have 93% that beta is different from 0. If you use 10% significant level, I say error because I want to make it easier to understand. So this 10% is that you allow probability that beta equals 0 is only 10%. But here, it's actually 7% below your acceptance rate. So you reject null hypothesis at 10%.
Okay, sir. So example, if 7% is more than 1%, so we accept the null hypothesis, right, sir?
Right. So meaning that here we only allow 1% to have beta equal 0. But our result shows that 7% that beta can have 0. So we only allow for 1%, but now it is 7%. Can you accept that? No. You got what I mean?
Yes, sir.
I try to provide you a simple explanation. Here, then you increase it. All right. Now I allow it to be beta can be 0, but only among 5%. It cannot be bigger than that, but you still find 7%. No, I don't accept that. All right. I allow beta to equal only 0 if it is 10%, but it is 7%. Okay, I accept that. So what it says here is that there is a probability that beta equals 0 is about 7%, but 93% you will obtain beta different from 0, assuming that you conducted survey with 100 different samples. So if you analyze 100 times, 73 times you will obtain delta different from 0, but about 7 times you will obtain delta equals 0. Is that clear? That clear now?
Clear, sir. Thank you, sir.
Right. So let me repeat this again, class. So when we say null hypothesis is different from 0 by delta j equals 0, of course, when you conduct the regression analysis, you obtain coefficient. And coefficient is normally different from 0. But when we say it equals 0, we mean that probably there is any chance that it is equal 0. We do not go straight forward that, okay, coefficient must be 0, you accept it. No, we say a chance. Is there any chance that delta 1 equals 0? If you allow, okay, I allow only 1% chance or 5% chance that delta can equal 0. If it is under this probability, I will accept it. If it is higher than this, I will not accept it. All right. So now you find that delta may equal 0 and there is about 7% chance. So you will not accept it. Okay. Now, guys, let me give you another example. Try to be more practical. You know, you develop a COVID you develop a COVID medicine. All right. You develop a COVID medicine. And what you want to know is whether this medicine is effective or not, right? So in order to say that your COVID medicine is effective, your null hypothesis, you will say that, okay, COVID medicine that you develop is not effective. It is not effective, meaning that the delta is equal 0. To what extent you accept this? In medicine field, most of the time, they only accept it, they allow only 1% chance that this is equal 0, meaning that if you give medicine to 100 patients, you would say it is effective if 99 patients is recovered by using your medicine. You allow only one error with using this method, meaning that 100 patients, only one patient is not effective case, right? Following me? So here, 1% is what you allow to say that it is not effective. There is no effect, right? Not quite sure if you understand me. Please clarify if you don't. Questions? Question everyone?
Sure.
All right. Yep. Go ahead, David.
The error 1, 5, and 10 is that we choose them by ourselves, right? We allow by ourselves.
Yes, normally it's you allow by yourself, but in social science field, it is the most standard acceptance rate, right? This is the most standard one, right? So delta equals 0, right? Delta equals 0. When do you reject it? What is the probability that you would reject it? You reject it if you allow it. That could only be true only among 3%, among less than 1%, or less than 5%, or less than 10%. This is the most standard way. When it comes to practical application in data, I will teach you guys how to extract table, and then you will see the standard way of reporting, and you make it make you very much easier in interpreting your data. You will see that. And again, in social science field, in economic field, most of the tests we only accept this 3 level. So right, by large, it must be lower than 10%. All right, we allow it to be not effective. We allow it to be not effective is only less than 10%. All right. Again, if I want to say that COVID-19 medicine is effective, I would accept only 9%. If I use the medicine with 100 people at least 90% of people get recover from using my medicine. I allow only the error 10%, the probability that it might not effective. All right. So it is not effective. If it is, for instance, 11, I found 11%, meaning that if I do it with, if I provide medicine to 100 people and 11 people did not get better of using my medicine, then I say that, okay, this medicine is not effective. So I accept null hypothesis that delta equals 0. But if it is only 9, if it is only 9%, with 100 people, only 9 people is not effective, 91 people is effective, it is acceptable for me because I accept it if 9% is effective, 10% is not effective. Question number 1. Right, we move next. Here is some guideline before discussing or interpreting your regression result. Previously, when you interpret your result, you just interpret your coefficient. From now, when you interpret your result, you either have to base on t or p value first. The best way is to look at p value first. All right. So here is the guideline for discussing economic and statistical significance. When you look at the p value that is less than 10%, right, we call statistical significant. All right. So if variable is statistically significant, then you can start discuss the magnitude of the coefficient to get idea of its economic or practical importance. So what it says here is that normally we interpret coefficient only if that p value is less than 0.10, meaning that we reject null hypothesis. All right. If we found p value is less than 10%, which is our significant 1%, 5%, 10%, then we say that this is the significant. We reject null hypothesis. So we accept alternative hypothesis that delta is different from 0. If it is different from 0, then you can interpret the coefficient that we call economic or statistic or practical importance. How much it affects. All right. We start interpreting the coefficient only if p value is less than 10%. All right. Following me? If p value is bigger than 10%, it is not significant. We accept null hypothesis. There is no, what do I say? What should I say? There is no meaning to interpret your coefficient if your p value is higher than 10%, or if you already accept null hypothesis. There is no meaning to interpret coefficient. Why? When you accept null hypothesis, you believe that delta is equal 0. But if you interpret delta, it means that delta is different from 0, right? It is not correct. So I say again, when you see null hypothesis, we say delta equals 0. We do not mean exactly this delta equals 0. We refer to the probability or the chance that this delta might equal 0. All right. So the fact that coefficient is statistically significant does not necessarily mean it economically or practically significant. So what it says is that when you reject null hypothesis, you accept alternative, then you have to interpret coefficient. Why? Because it may be statistically significant, but coefficient might be very, very small or close to 0. If it's close to 0, there is no economic significance. But again, we can only interpret coefficient only if there is no endogeneity, there is no omitted variable bias, there is no violation of zero conditional mean assumption. right? All right. So if variable is statistically or economically important, but has wrong sign, all right. For instance, if you found weight has negative effect, all right. You found, sorry, you found that education has negative effect on weight. Then it may be the case that the regression model misspecified. When we say misspecify here, probably you omitted some variable, or probably you include irrelevant variable. So, guys, to obtain a good regression result is not easy. You have to double check every variable that you include. Is the sign is correct? If it's not correct, why? Is it because of your model or because of your data? I say again, right? If you find, for instance, education has negative effect on weight, is it true? Normally, it's not true at all. If education has negative effect on weight, why you study? So you inform the Ministry of Education said, no, you should not promote education because it does not contribute to wage at all, right? So be careful. You have to carefully look at the result, the sign of the coefficient. If it is significant, if it is not significant, that's okay. Wrong sign or correct sign doesn't matter for the insignificant, right? So here it may answer to, I forgot it, the question earlier. If a variable is statistically significant at usual level, so the usual level is 10%, 5%, or 1%. All right, this is the three standard significant level that you should use to compare with p-value. If p-value is less than 1%, you say, all right, we reject null hypothesis at 1%. If it is higher than 1 and lower than 5, you say, all right, we reject null hypothesis at 5%. But if it is higher than 5 and lower than 10, you say, we reject null hypothesis at 10%. However, if p-value is higher than 10, you say, we fail to reject null hypothesis. All right? Class, there is another idea. For instance, you believe that education must have significant effect on weight. If you do believe that and with your own data and you find it is insignificant, then you have to consider to drop some variable. It is collinearity issue, right? You remember when there is a collinearity issue, variance is large, standard error is large. When standard error is large, t is small, right? Because t equals coefficient minus standard error. When there is multicollinearity, standard error large, t high, t small, p high. All right. So again, when you found it, significant effect, but different sign, wrong sign here. All right, wrong sign. Double check your model. If you find that it should be significant but it's not significant, double check if there is a multicollinearity or not. I will teach you how to check multicollinearity in data today. All right. So this is how you should interpret your regression model. Start with statistical significance first. If there is a statistical significance, then you move on to economic significance. When it says statistical significance, we refer to P is lower than 1%, 5%, or 10%. Or in short, it must be less than 10%. Questions? Can you follow me?
Teacher, significant level is not correlation, right?
No, it is not about correlation. David, correlation is another. All right. When we say correlation or relationship here, only if p-value is less than 0 only. Sorry, if p-value is less than 10%. If p-value is less than %, you may say, okay, you know, if it's just wording, you may say, okay, X has significant effect on Y, or you may say X significantly associated with Y, or you may say there is a significant relationship between X and Y. It is not correlation. It can be association, relationship, or effect here. Correlation, you have to go back. We use another one we call correlation test. The coefficient, correlation coefficient, and that R is between 1 to -1, right? You probably you need to review the last lecture material a bit. So correlation is not the same as relationship or association, because correlation does not tell you the direction. Do we answer your question, David?
Thank you, Chair.
There is a message from, what do you mean by wrong sign? Wrong sign here is the sign of the coefficient. Again, for instance, you want to estimate the effect of education on weight, right? What is your assumption? You believe that education increase weight. Agree with me? Education should increase your weight, right? However, if you run regression, you find that education has negative sign, has negative significant effect on weight. That we call wrong sign. All right. Again, this wrong sign, you only need to be careful only if it is statistically significant, only if p-value is less than 10%. Is that clear? With wrong sign?
Yes, lecturer. Yes.
All right, another example. I want to estimate the effect of COVID-19 on student dropout. I believe that COVID-19 must have what? Negative effect on the dropout, meaning that if there is a COVID-19, dropout might high. But what if I found that during the COVID-19, dropout is very, very low? That is wrong, right? That is wrong. Another example. I believe that COVID-19 has negative effect on income, right? What if I found that those who experience COVID-19 during the COVID-19 compared to previous year, all right, COVID-19 has positive sign. COVID-19 contribute to household earning. That's wrong. That's different sign. But again, we only concern on the sign only if it is statistically significant. When we say statistically significant, P must be lower than 10. Or if you like, T must be higher than C. P value must be higher than critical value. But from now on, I only talk about P value. It makes your life easier. You can compare it directly with significant level. Any other questions? All right, so we move next then. We discuss, what is that? Now we move on to confidence interval. What is confidence interval? Confidence interval is the interval of your estimate. Is the interval of your estimate. All right, so to construct confidence interval, it is your estimate minus critical value multiply standard error. All right, and this is we call lower bound of confidence interval, and here if we plus, it is the upper bound of confidence interval. And normally it is on your choice. If you want to have confidence interval at 95% or 99% or 9%. If you accept to have 95% confidence interval, critical value must be 5%. So meaning that you allow error to have only 5%, right? You allow to have only 5%, the error. All right. So how to interpret confidence interval again? the bound of interval are random. What does that mean? It means that, for instance, if you estimate your coefficients, that interval will tell you the range of value. Guys, what you are interested is the population parameter, right? But what we analyze so far is only sample estimate. We don't know what exact number of the population parameter. So the coefficient itself, it's not really the value of population parameter. In this case, you need to construct confidence interval. You must say that, okay, at least I believe that the population parameter must be between this value from lower bound to upper bound. All right. So here, in repeated sample, the interval is constructed in the above way using this equation. It covers population regression coefficient 90%, 95% of the case. What it says here is that we believe that with 95% confidence, the population parameter must in this interval. Now, to understand more, let me go to the example. All right. This is just a quick way how you calculate the confidence interval for 99%, 95%, and 90%. All right. Here, this is an example. All right. The model for firm and the expenditure, the effect of what? Either, sale on spending on R&D or whatsoever. All right. So here we have our model log of R&D, spending on research and development, log on of annual sale, and profit as percentage of sale. All right. Then we have, this is the intercept, right? This is the slope, or we call it coefficient for sale, coefficient for profit as percentage to sale. And then we have here is observation is quite small, only 32. R square is very high, almost 92%. Degree of freedom is 29 because this is n minus k minus 1. Critical value is 2.045. How do you compute lower bound? So let's compute the lower bound for the variable. What is this variable? The variable of annual sale. All right. For instance, you want to know the effect of annual sale on spending on R&D. So to calculate that, the confidence interval with this 95% confidence. All right. So earlier we have what? We have here the delta minus C multiply standard error, right? It's lower than B, and then again delta plus C multiply standard error. So here, you look at this first, the effect of annual sale. So the coefficient of annual sale is 1.084. Plus or minus, it is lower bound or upper bound. Minus is lower bound, right? So if minus, critical value 2.045 and standard error is 0.60. So lower bound you get 0.961 and upper bound you get 1.21. Following me? This is you have the lower bound. This is you have the upper bound. Following me with computations?
Teacher, would you elaborate this again? The equation.
All right. This equation here is, to calculate the lower bound from here, calculate the lower bound just like this. Delta J minus critical value multiply standard error. You only need to calculate this lower bound to understand lower bound, and this is the upper bound. Right?
Yes, sir. Thank you.
All right. Next, guys, you can download this slide from the lecture note folder. By the way, I already uploaded. All right. So here you simply calculate it yourself. So what is the coefficient for this sale variable? Here is the coefficient, right? And what is this? This is the critical value. And what is this? This is the standard error. When you use minus sign, you will obtain this lower bound. This is lower bound. Let me say L. This is the upper bound, U. So if you do math yourself, if you do the math, right, you will get lower bound is minus 0.61, upper bound 121. What does it say? Here is the interpretation. The effect of cell on IID is relatively precise estimate, as interval is narrow. Moreover, the effect is significantly different from 0 because 0 is outside the interval. All right. So, guys, if you want to know if it is significant or not significant, you can simply calculate t here because we don't have p value here. All right. You can simply calculate t. How to calculate t? Coefficient minus standard error. But not but. You will see that, all right, this log cell has significant effect on spending on R&D. And that coefficient is 1.084. If you look at this 95% interval, you see that the lower bound is minus 961 to 1.21. What it says here is that if you, all right, now you only analyze one data. If you analyze data 100 times, 100 sample, 100 different sample, 95 times, you will get coefficient between this value, between 0.961 to 1.22. So you see, there is no chance that your coefficient equals 0 because 0 is not in the interval. 0 is not in the interval. It's consistent that you will find that this is significant. Why it is significant? When it is significant, you reject null hypothesis. You say that delta is not 0. If you look at confidence interval from the lower bound to upper bound, 0 is outside of the interval. So meaning that if you analyze the data 100 times, 95 times, you will get the value between this, between 0.69 to 1.21. You see, 0 is not in the interval. All right? It is consistent to the statistical significance. When you found statistical significance, you reject null hypothesis saying that delta equals 0. What it means is that there is a chance that delta equals 0. But here, you prove that confidence interval tell us that 0 is not interval. 95% you will get coefficient different from 0, and the value is between this. All right. So with your sample, with our sample analyzed with this example, the coefficient is this. The coefficient is 1.084. If you use any other data, the coefficient should be between this lower bound and upper bound. Questions? All right, let's have a look at another variable. You will see something different. If you want to calculate the effect of profit as percentage of sale, all right, the same math, right? Coefficient 0.02, all right, plus minus critical value 2.045, multiply standard error 0.2. Sorry, this is wrong. This should be 7, not 8. Standard error here is 7, and this is not 8, but this should be 9. All right, you will obtain this value. You will obtain this value. The lower bound is minus 0.045. The upper bound is 0.479. You see, class, with this variable, you see what? Lower bound is minus, upper bound is positive. So it says that 0 is in this interval. 0 in this interval. So if you look at t or p value, I believe, if you don't look at the p or t, if you just see confidence interval, you fail to reject null hypothesis because there is a chance that beta might be equal 0 because lower bound is minus, upper bound is positive. See? So profit as a percentage of sales has no significant effect on spending. In other words, we accept null hypothesis saying that profit margins might equal 0. So if you look at the interpretation below, this effect is imprecise. The estimate as in interval is very wide. It is not even statistically significant because 0 lie in the interval. Right? Questions? Are you following my explanations? Question, everyone? You following me? Following me, class, with confident interval? I will stop here for the lecture. We're gonna move to hands-on exercise using data. Lecture, we have p-value, but why do we need confident interval? All right, p-value only tell you whether the probability is rejecting null hypothesis or not, but it does not tell you what is the true coefficient, what is the coefficient of population. All right, remember our original goal is to know, for instance, you want to estimate the effect of education on weight, right? But you only analyze for a sample. But what we really know, we want to make inference. Again, when we say we want to make inference, we want to say something to population, all right? So when we find, for example, in this case, the coefficient is 0.84. So we find that from this sample, the coefficient is only 0.84. But what is the true effect? You don't know at all, right? So if you do it 100 times, you will believe that the true effect is between these two lower bound and upper bound. So confident interval, first of all, tell us the value of the true parameter. We do not know exactly, but at least we know the range. Second of all, it tells us the distribution. If you do another analysis, the value must be in this value. If we only focus on p-value, we only believe in your own data. What if you have another data? You don't have that. Okay, if you use another data, for instance, how do we know that? So what if the other data have different p-value? It's gonna be different result, right? So we have to construct confident interval. We have to say something. If you analyze using different data 100 times, we believe that the value must be between this, must be something which is different to similar to our result. Do I answer your question, Kim Hua? But again, in practice, we do need confident interval. But in presenting your data, in presenting your result, class, you don't really need, you don't really look, sorry, mostly researchers do not really look at confident interval. But here, it's just a must that you guided to know the confident interval. I see the term confident interval. So you are confident that population parameter is between this. Or if you analyze the other data, you are confident that 95% time that the result must be between these two values, lower bound and upper bound. And I say again, normally if the interval, if 0 is inside the interval, normally it is not significant. It is consistent with p-value or t-value. However, if 0 is in the interval, you may find that it is not significant. It's always consistent. I will tell you when it comes to our hand-on exercise, and you can compare the consistent finding from p-value to confident interval. Good. Any other questions?
Yeah. Degree of freedom 2. How do we find 2?
2 is the K. You remember the degree of freedom? Degree of freedom is what? Is K, is N minus K. Degree of freedom df equal N minus K
minus 1.
minus 1, right? And what is N? N is 32. What is K? K is the number of independent variable in the model. You look at here. How many number of independent variable? Log RD is the dependent, so not count. So you only have annual sale, you only have profit as percentage of sale. So we have 32 minus number of X, 2 minus 1. 1 here is constant. So you will get the constant here. I mean, we refer this is also counted as 1, right? So 32 minus 2 minus 1, and you will obtain 29. Clear?
Thank you, Chair.
So again, K or 2 is the number of independent variable that you employ in the model. All right. If there is no other questions, let's close the lecture for the time being, and let's move a little bit to hand-on exercise. All right. So class, please open your data, and also, all right, wait a minute. All right, close here. Let me share the full screen. All right. So class, you can download the hand-on exercise file from the lecture note. All right, from lecture note, and week 9 data, this file. All right, week 9 multiple linear regression data. All right, the file that I am going to use to explain you next. We go into detail with this file. And also for those of you who use data and you cannot load the data online, you cannot load the data online, you can download data from today hand-on exercise in data folder. We use this data, IE401 2. All right, we use this data for hand-on exercise. For those who cannot load data from the internet, download this data and the file. We start the data application in a minute. All right, give me a minute. All right, everyone. Open your data. Also, open the file, the data file, the hand-on exercise file. Where is it? This one. All right. Have you downloaded the file and data? Ready to continue? Can we move on? Can we start our hand-on exercise now?
Yes, like.
All right. All right. So, guys, I'm gonna start with this file. All right. Today we're gonna start with multiple linear regression analysis. All right. So today, we're gonna start with example of multiple regression analysis. All right. With footnote below is gonna explain the output in detail. All right. The analysis use the data file about score obtained by elementary school. So our data here is school level, right? School level data. It is not person level, not household level, or whatever. This is only school level, all right? And the data is one to predict AP00 from this L, meal, year-round, mobility, ACK3, ACS 46, full, emerge, enroll using blah, blah, blah. All right. So, guys, here we do not know the variable name, but don't worry. We only look at some variable. So now please open your data or open your data. And there are two ways to load the data. Either from the link here, you can use this data directly. Okay, use blah, blah, blah here. Or if you cannot load the data from this web, all right, you can load the data from the data I share with you. All right, so I am going to, don't forget to work with do file. All right, so let me open my do file, the last do file. All right, so where I am now, so today is multiple linear regression. Linear regression, right? So what I'm going to do is to load the data, run. All right, I obtain the data now. How about you guys?
Teacher, we no need to clear the previous data.
Class, look at my do file. So normally, if you just start your, for instance, if you just open your data, it starts with blank. There is no data in your data right now. All right. In your do file, you can continue. But when you analyze, select what you're gonna run. You want to run. You want to do file here. All right. So in fact, there are many. But if you just put your cursor on the do file and run, it will run the whole do file. It's gonna run the whole do file. Don't do that. Only runs what you want to run. All right. Select it. Click run. All right. Then we start with no database with this database. If you already have existing database in your data, you can have clear first and then use the data, right? Then you load the data in your data. Is that okay with you now?
Yes, sir.
All right, Sinh Ha. Can you load the data now, Sinh Ha?
Yes, sir.
Does anyone have any problem with loading data? Guys, if you don't tell me, and when I move on, you cannot follow me, I have no idea what's going on. If you have any problem, if you face any difficulty, let me know. If you don't want to talk, even though I encourage you to talk, drop in the chat box like Kim Hu did. All right. If you stay silent, no way I can help you. Hopefully we have at least a member from each group that can follow me. All right. Hopefully everyone loading the data in your data now. Next, we are going to run multiple linear regression. All right. So what we are going to do here to run regression, as you all know, here we have multiple independent and only have one dependent. All right. I have a message. I'm happy to see that. Wait a minute. What is that? I cannot download the file. Like, you mean you cannot extract the data from the web, like what I did, or you cannot download the data from the folder I upload? Muni. So what I did here is I load.
Teacher, the files that you want us to download from the folder.
All right. So here, right? Select it, and then download. Can you try again? All right. General channel. Go to file. Move to data. Select it. Download. And please store it in your directory. Can you do it now, Mini? Can you download it now?
A little bit like.
All right. Or you can try loading the data from the web as mine, but you can't use that data. Let me know, everyone. Ask the question. Tell me, like what Muni did. If you stay silent, no one can help you except yourself. This is for today. This is for next week. All right. Only in Lamapi 2.
Teachers,
Yep.
what API rows stand for?
Academic. You can have a look at this data set. Have a look here, AP00. So basically, this is academic performance index, if I get it correctly. Yes. Academic performance index or score. All right.
Yes, thank you, sir.
All right. And then you can look at the other variables such as L. This is English language learner. Meal. This is per capita free meal. RD, RD, year-round school. And then ACS K3. This is average class size for grade 3. ACS 4 to 6, average class size from grade 4 to 6, right? This is elementary school. Immer here is the per capita. I don't know what the full name. How is it now, Mini?
Teacher still cannot. I don't know how to do.
You cannot download it still? So let me send you through this chart then. I send directly to the chart and let's try to download this from the chart. All right. So here, data, and that data, I forgot it. It will be this one. Okay. Can you download from the chat box? Can you download from the chat box? Does it work?
Teacher, I just don't know that after download and what do we need to do next, like to process it.
All right. After download, move your data to your directory. You remember your last directory that you store your data in data? All right. And then you can click that directory to open data. Click that data directly. All right. For instance, here, my data is in for instance, my directory is, I go directly to my directory where I store data. All right. Then I click it. Just click it. Open it. Then it's here. All right. How is it now, Winnie?
Teacher, I think you should continue your lesson first and I try later.
All right. So there's no much hand-on exercise, not many technical tools, if you understand from our private lecture. So now, class, let's move on to our multiple regression. All right, we are going to run this regression analysis. All right. So as you know, to run multiple regression analysis, we use regress, right? Or simply rig, the same, rig or regress. All right. But here I copy and paste in my do file. So regress p00 is my the first dependent, my dependent variable, and the remaining are independent variable. And after that, run. Click do, right? Then I obtain regression result. Right? How about everyone now? Have you obtained the result? Have you obtained the result? Any problems? Challenge?
No problem, teacher.
All right. So now let's move on, class. As you see, the result is the same to what we constructed or computed for simple linear regression. All right. But so far in multiple linear regressions, you also know what is root mean square. I don't know if you remember this. All right. But so far, you know, this is number of observation. You know, this is the R square. This is, all right. The main point is number of observation and R square. And this is just they construct residual, sum square residual, sum square modal, sum square total for the product to calculate R square. But now, what I want to do now is to quickly look at the table and go together, not go into the detail. You guys can spend time to read the detail of the text. All right. But here, first, from what we discussed today, we should start with statistical significance first. By we mean by statistical significance, we look at either t. So if you look at t, you need to remember the general rule of t statistic. The general rule, if you use t, if you want to interpret based on t, guys, if you want to interpret based on t, we have to go back the general rule. The general rule, right? The general rule of using t is what? What is here? What is the 5% level? T critical value for 5%, critical value for 10%, for 5%, for 1%. You guys have to remember the three critical value if you want to interpret based on t. But so far we already learned about p, right? P value of t here, this is already constructed. All right. So for instance, if you remember, we must interpret p first. before we interpret economic significance. So economic significance is coefficient, statistical significance is p-value. Now, let me ask you a question. For the first independent variable L here, do we accept or reject null hypothesis? Feel free to answer either in the chat box or unmute yourself and talk directly to me. If you want to talk, reply to me silently in your heart. Do we accept or reject null hypothesis? You see here P equal 0.00. Accept or reject? Accept or reject? What do we mean by accept or reject? Remember, null hypothesis always state that P delta, our delta equals 0. When you see P value is dot 0 very small here, you reject null hypothesis, right? You reject null hypothesis. So in this case, to be honest, you might say there is no probability. When you see 0, 0 here, we would say, but in fact, we won't say there is 0. But the probability that delta equals 0 is almost 0, right? The probability that delta equals 0 is almost 0, because here we have 0, 0, but we will not say 0 because we do not know what is the other decimal that has only round up to 3 here. All right, let me say this again. Our null hypothesis is delta equals 0. But here, what we found here is that the chance, the probability that beta of L equals 0 is almost 0, right? So we reject null hypothesis. Since we have 3 significant levels, 1%, 5%, and 10%, and we have here 0.00, it's exactly lower than 1%. So we say we reject null hypothesis at 1%. So after we reject null hypothesis, then you can interpret the coefficient. Then you would say, if yield, what is yield? I also don't remember yield, then I have a look back at my variable. Yield here is the English language learner, all right? English language learner. So I would say, if English language learner increase by 1 unit, the academic performance index will be decreased by 0.86%, right? I interpret coefficient only this. We check, we have p-value less than 10%. Following me? So, since we have coefficient is negative, right? You look at confidence interval, 95 confidence interval. The lowest is 1 minus 2. The upper bound is, sorry, the lower bound is minus 0.2. The upper bound is 0.4. Is 0 in the interval or outside the interval? You see? 0 is outside of the 95% confidence interval. There is no chance, or we would say 95%, we found that this confidence interval will not have equal 0. If you conduct, right? If you analyze different sample, you know, the coefficient that you might get is between this lower bound and upper bound. But in our sample, we get this. Different sample will be between this. All right? Following me, my interpretation, everyone. So step by step, we start with P, and then we go to coefficient. And to confirm, you can have a look at confidence interval. But again, normally confidence interval is not an interest for interpretations. Following me? Remember, class, we only focus at interpretation. Remember, what we interpret here, we can only interpret here is only coefficient is unbiased. All right, only this coefficient is unbiased. Only if assumption 1 to 4 are met. Mainly if zero conditions assumption is met. Mainly if there is no endogeneity. Mainly if there is no omitted variable bias. And also we assume that standard error is also unbiased or correct. That assumption 1 to 4 are met. If we are not sure with this assumption, we normally cannot, we will not interpret this coefficient. That only for economics, but for social science, it's okay. I mean, for instance, for those who study psychology, social science degree, they may interpret coefficient. But for those who study impact evaluation, you cannot interpret this. But that's okay. You can say that for now. Following me? Question, please.
Teacher, can you interpret again on the coefficient?
All right. So the coefficient here, first, you remember how we interpret in multiple linear regression. In multiple linear regressions, one unit increase independent variable. In independent variable affect one unit independent variable. So here, since we have negative sign, all right, if English learner proportion of English language learner increase by 1 unit, for instance, if this is in percent or in number, it will reduce the academic performance by 0.86. Again, we only interpret this, only we see that, oh, there is almost zero chance that coefficients, there is almost zero chance that coefficient or our parameter is equal 0. To answer your question, is that clear?
Yeah, teacher, thank you.
All right, class, start with P. Don't start with coefficient. P first. And again, confidence interval is also consistent with our result that we interpret this coefficient. Questions? Class, if you have a look at the other variable that is constant, the average class size for grade 3. You see P value here. See my, wait a minute. Here, this P value here, 0.559. What it say? Our null hypothesis is that delta equal 0, but here, there is about 60% chance that delta might equal 0, right? There is about 90% chance that delta of ACSK3 might equal 0. So we fail to reject null hypothesis, or we accept null hypothesis. Then you don't have to interpret this coefficient. You don't have to interpret this. Here, if you look at the confidence interval, you see the interval is quite wide. The lower bound is minus 3.1. The upper bound is 5.7. 0 is in the interval. There is a chance that our delta is equal 0, right? So you don't have to interpret. So in short, you might say, all right, there is no association between average class size for grade 3, for grade 3 and academic performance. Or you might say average class size of grade 3 has no effect on academic performance. Then that's it. You don't have to care about coefficient. By the way, let me relate this to Kim Hoo's question earlier. For instance, class, here, our p-value is significant, right? And coefficient is negative. If you find that this coefficient is negative, it's not correct, it is not correct, then you have to explore your model again. How you explore? Delete some variable, add more variable. if it is significant and wrong sign. When we say wrong sign, you look at the sign here negative. Do you believe it is negative or positive? If you believe it's positive but it is negative, you need to readjust your model. Dropping some model, dropping some variable, or adding some variable. Questions? Are you following me? Following me, class? Or I am alone?
Teacher, can you explain again when the coefficient is negative? So what happened?
So here, when it doesn't mean that when coefficient is negative. What I am saying is that when the coefficient give you wrong sign. For instance, you expect that ear may have positive effect or positive relationship with academic performance. But now what you found is negative. You expect it to be positive, but now you found it's negative, right? So it is different. You believe that the sign is wrong. If that is the case, you need to reanalyze it. You need to, meaning that now it is wrong. Your model is wrong. How it's wrong? Probably you include a relevant variable, or probably you miss some important variable that you do not include in your model. However, again and again, you only concern if it is wrong sign when it is significant. If it is insignificant wrong sign, don't worry. Because confidence interval here, confidence interval of insignificant variable can be negative or positive. All right? You only care the wrong sign of significant level. Following me, Mani?
Yes, like, thank you.
Question everyone? If you understand this, you guys, if for those who are using cross-sectional data for your group assignment, you can move forward. Actually, you don't need me anymore probably, but we may discuss some other information next week. Next week or the following week we discuss qualitative information, heteroscedasticity, some additional point, but not that important as what we covered so far. Questions?
Teacher.
Yep.
Quarterly data, is it a time series or cross-sectional?
Quarterly data at what level? You have to know what. No, you know when we say cross-sectional when only one time survey, only one time data. If quarterly, this is not one time, it's multiple time. So if it is multiple time, it can be either time series or panel. All right. If it is time series or panel, we will cover it in I think around week 10 or week 11. We will discuss about the model that we use with time series or panel. So again, to answer your question, if it is quarterly, it can either time series if there is only one interest. For instance, if that quarterly is for Cambodia, that is we call time series. But if it's quarterly for Cambodia and Thailand and Vietnam, that we call panel data, right? If your unit is country, however, if your unit is a firm, for instance, it's still panel because you will have quarterly data for company A, company B. So look at time and your unit. Is that clear, David?
Thank you, teacher.
All right. So it is now already 7. Let's have 30-minute break as usual. Let's return back to the room at 7:30. Our 30-minute start now. I see you after break, class. Hello, everyone. Are you back in the room?
Yes, like we're back.
Right. So let's continue. So I will not go into the detail of the interpretations. You can go through yourself, A, B, C, D, E, F, G, and so forth and so forth. All right. It is a note. For instance, on K, there is an explanation interpretation below. M, so you can go into the detail yourself. I will not go into the detail. So remember, when it comes to interpretation, you start from P, you go through coefficient. All right. And confidence interval can be used for, checking, but normally in report or presenting the result, you will not mention about confidence interval. Only a small number of paper mention confidence interval. Any question, class, about the interpretations? Any questions before we move on to interpreting results? No questions? All right. If there is no questions, let's continue. So as I said, I will not spend the detail here. You can read the text yourself. But what I am going to take you next is how are you going to extract, this regression result into your report, right? How to extract this. So one way, what you have to do this is you have to do it manually, right? For instance, I have to copy and pass it into the Excel, right? Here, as you can see, I copy tabboard. Then I move to Excel. I open it, all right? I pass it here one by one. I pass the first part. Then I scroll down. I pass the second part. All right. Then you rearrange it. You rearrange the value yourself. What is the coefficient, standard error? What you want to report? Then you do it manually. You do it manually. All right. So again, if you want to do it manually, you have to copy and pass the result into Excel. How you do that? You have to copy part by part and make sure to copy table. However, this is not recommended because I suggest you from the beginning, I want you to use data because data is more on programming that you can, save time to do it. So normally in data, there is a command called outrick. If you get back to the file here, to rearrange your result in standard format, here we can use this, right? Let me copy this, sorry. All right, let me copy this command and pass it here. This command class is used only after you run regression. For instance, now I run regressions. All right, I run regression and I directly use this command. The command starting outrick, right? Outrick is the command name. Using, so you have to type this. Using is exactly the same. And this is your file. What is your file? So I name the file name result MLR, result multilinear regression. This is what you have to give the name of your file. All right. So outrick using your file name dot meaning that I want to produce word file, right? The extension doc is the word file, and then SE here I want to import standard error, and I give them star level here, star level with 10%, 5%, and 1%. C title, this is the title of the column title. Put 2 quotation, and then I give the column name MLR1, multiple linear regression 1. Replace in case there is any existing document name result MLR. Following me one by one. So if I write this again, all right, let me write it. I use Auric, okay, using. Then you decide what is your file name. Result slash MLR dot. This is the document, the word file. All right. So this is what you have to fill in.
Sure.
Yep.
Sure. I saw Word document. They have 2 extensions, one docx and one doc normal, like that.
That doc normal is a template. That docx is the update version. So here instead we use the doc. Docx is the, for instance, I believe that's from 2011 versions, but the old version is in doc format, in doc extensions. And for that doc normal is the template, all right? The template of the version. So normally the extension is doc or docx. So here we use doc in case you have the old versions. You cannot open the file, all right? So give the name .doc slash C. I want to import standard error. Normally coefficient is extracted automatically, but here we want to extract standard error as well, because it is very important. Every researcher, especially applied economics, they want to see your coefficient and standard error. Why? Because to obtain coefficient, you need to meet assumption 1 to 4. And if you want to have standard error, you need to have assumption 1 to 5. T and P is just the product from coefficient and standard error. All right. So here, then you have star level, and then always use this three significant 10, 5, and 1. This is in percentage. Then C title, the title of your column. All right. Slash I put it MLR1, and then replace if there is any existing file named this. I replace this with the new file. Following me? Everyone?
Teacher, can you scroll to the end? Oh, okay, thank you.
Don't just copy and paste, but make sure that if you want to run it again, you know where to modify. Modify this part and modify this part. Only these 2 parts. All right. Replace. You don't need it if you believe that there is no file name MLR doc in your folder. All right.
Teacher, the outrage cannot be identified in my SASTA system.
Wait, because you are the first time user. You have to install it, but now I want you to finish writing this command first. Then we will go to the next step. Follow me, everyone.
Yes, sir.
If you follow this, all right, if you are first time user, you cannot run this. But I, for instance, it requires something. I forgot closing parenthesis. I run it. Wrong again, because I do not run regression. I have to run regression first. Run regression now, then run Auric. Invalid.
You put
Invalid.
10.
Auric using result R1. Oh, sorry. Good. You found the error. The doc already exists. You see, in my folder, the doc is already exists. If I run this, it does not allow, because there is a file name result MLR3. Because I touch another sessions and I use the same file name. All right. So I have to use replace. I have to replace the existing one. You see the error message here? It tells me file result doc already exists. So I have to add replace. Then I run it again. Successfully now. See? I believe that you guys all do not successfully install it. So what you have to do, now you go to your data and go to search and type Outreach. Type this one first. Make sure you have internet connection. You have to install it. Are you following me? Type Outreach. Got it?
Teacher, my version doesn't appear the search bar there.
If there is no, you click somewhere. No. Help. Can you click help? Can you click search? It should be under help. Can you find it?
Yeah, teacher, search here.
All right. In this search, then you type Outreach. Okay. And then enter. Does it work? No result. How should I find this?
On the chat.
After you type Outreach in the search, if you have internet connection, it will show you a list. A list that suggests you to install something. But what I want you to do, if you find this, all right, you scroll down to here, SG974, and then click. You following me? When this window appear, click follow SG. Find SG starter package 97_4. There is a link here. You click it. Are you guys coming to this page?
Yes, sir.
Yes.
Click here to install. See, click here to install. Now it is installing. Now it's already done. After you are done, run the command again. Run the command Outreach again.
Now it works. Like.
Right, good. So you already successfully installed Outreach command. All right. Anyone have any problem with running Outreach? Guys, this is very important. It saves a lot of time. And I will tell you that with this standard result, it's also easy for you guys to interpret it. You don't have to go into the detail. Have everyone obtains the standard table for regression result? Next, I will tell you what if you run multiple regression. You can, merge multiple regression into just one model using this command. Anyone has any difficulty, problem with obtaining this standard regression result that I show you guys on my screen?
Sure, the result cannot be opened from Word file.
We can.
They said Word file unreadable content in result.
That probably your directory is too complicated. You have to change your directory. How you change your directory? If you don't remember from the beginning, you can follow me here. You click file and here change directory. All right, change directory to somewhere not, you go folder again. So there are some multiple steps. Find an easy directory that you click just only one or two folder and then run it again. Can you try? Does it work? Change your directory. Change your working directory. How is it now?
Sure, I can't open the file. Is the problem?
What do you mean by you can't open the file? By the way, let me ask you first. Have you obtained this similar table as mine on the screen? Devin?
Yes.
All right. All right. Then we will get back to the file later. If you obtain it, I don't know. Probably, I believe that because of your directory. But now, does anyone have any problem? Have you guys successfully installed our command? Have you guys successfully obtained your result? Guy, have you obtained the result?
Teacher, it's my result already show on the table, but I can't find the word file.
The word file is in your directory. Where you store it? Where is your directory? Guy, since we start Stata, I also when I first start teaching you the Stata, I told you guys to carefully select working directory. Where is your working directory? All right. So for instance, if you want to know your working directory, probably you click file and then change working directory. This is my current working directory, right? For instance, if I click, here, this is all my working directory, open recently. They are all my working directory. To open Word file, you need to know where is your working directory. Do you have any idea? Here, where you store it? Where is your working directory?
Yeah, teacher, I searched it and found it now.
All right, good. All right, wait a minute. Don't go to your Word file yet. But what I want to tell you here is that this table here, as you guys see, this is the summary result from the whole regression. So if you interpret based on this result, it's good. So before you extract to this table class, before you extract to standardized table, make sure you obtain good result first. When I say good result, you do not obtain any wrong sign. You do not obtain any wrong sign. You get the result that you expected. If it is not expected, is your model wrong, or you can't have any reason to explain it. Otherwise, it is not certified result. So after you obtain certified result, then you can extract it into this table. All right? And with this table, it's very easy to interpret. First, earlier I told you guys that you need to look at p-value, but now you don't have to look at p-value. You just look at the star. All right? The variable that has the star, it is significant at 1%. You see the note here. Star 3, p-value less than 0.01. See that? So quickly you see, The variable that has no star, they are insignificant variable. We accept null hypothesis for that variable. See, easy, faster, right? And if you have to copy and paste yourself, it takes a lot of time. In here, this is the coefficient. The number in the parenthesis is standard error. Star tell you the p-value. If star is 3, it is lower than 1%. If star is 2, it is lower than 5%. If star is 1, it is lower than 10%. If there is no star, not significant. In the table, it also, report R square, report N, which is number of sample size or observation, and also constant. See, it helps you to interpret your result as well. So you can just quickly look at the star and say, okay, the significant variable are yield, meal, year-round, mobility, ACS 46. That's it. The other independent variables are not significant. Then you can start interpreting. All right, yield is significantly associated or affect academic performance at 1%. So 1 unit increase in yield, it associated with 0.86 decrease in academic performance. Then you go to the second one, third one, fourth one, and then to the last significant variable. Following me? Following me, guys? Questions? So far, so good or not so good? You following me? Yes or no?
Yes, like.
All right. At least I have here reply me. All right, guys, this is just one regression result. Now, assuming that you run another regression result, the same dependent variable, but now you want to run a regression result. This is your original regression result, but now you simply want to run the same regression result, but you delete one independent variable in row. Okay, you believe that, oh, I want to try another regression result, but now I delete it in row. Right? Wait a minute. Con here constant, the intercept. Delta 0. That is delta 0 from our regression result. Got that? If I scroll up here, it is this value con here, constant here, intercept, delta 0. All right? So class, here is our original regression. Now I want to run another regression, but delete one variable. All right? So I run it. All right? And now I want to import the regression result into the same table. What should I do? In order to do that, all right, I copy the above outreach command, I pass it using the same file name, but now this is new regression result. I change the column from column MLR1 to MLR2. This is the regression result from MLR2. The difference is I delete one independent variable. And in order to merge this result with the existing one, we have to use merge. Is that merge correct? Let me have a look at the file. I don't remember it. I guess merge correct. All right. You have to use merge. So merge here is that you want to merge this MLR2 result to the MLR1 table. Following me, guys? If you run regression in this outreach, bang, you got it. MLR1 result, MLR2 result. And if you look at the table, the difference here is that LR2 does not have enroll variable. Don't forget class, not replace, delete, replace, and put merge. Otherwise, you will not obtain full color. Following me? You following me, guys?
Teacher, so what does it mean by doing this, like or two?
So normally, for instance, if you suspect that, all right, there is something wrong in your model, or probably you want to run different model and then you want to compare the result. You want to put it in the same table like this. All right. You want to compare result. For instance, if I exclude enroll from my model, you see that the coefficient from year is increased from 0.8 to 0.9. See? And for meal, it is not that much sensitive. Year round is increased from 19 to 23. You see, for mobility, it is from 1.3 to 1.30 to 1.60. You can compare it. But for AC46, it is still almost the same. All right. So the purpose is for comparison, and also you want to present multiple results in one table. Otherwise, you have two tables that take a lot of space, right? You don't want to take too much space to present your regression result. Is that okay?
Yeah, teacher, thank you.
So if you read any good paper, author rarely present one table for one regression. Rarely. They often present one table for a few, 2 or 3 or 4 or 5 regression result, not just one table for one regression. That doesn't make sense. All right. But here you still, if you compare these two results, you still find the same significant variable and the same insignificant variable. All right. You don't have to interpret constant. All right. This is the way how you extract the standard table from regressions. All right. You can use only one regression result or two regression results. Is up to you. All right. Based on your star, you can follow the journal or follow the paper that most relevant to your study. You can follow that star. All right. If you want to, for instance, report coefficient in one column, standard error in one column, you have to do it manually. Manually, like I showed you earlier, here you have coefficient in one column, standard error in one column. If you want to report coefficient in one column, standard error in one column, do it manually. But if you have to do that and you want to report star, you have to do it manually as well. Okay, this is star. Okay, I believe this is 3 star, 3 star. This is 2 star. This is 3 star. This is no star. Then you have to give the star manually. Right? You have to do it manually, and at some point there are gonna be some unintentional mistake. All right. All right, guys. Now you already extracted the table. You need to copy the table and pass it in your report. Then you have to go to your directory. Where is your directory? In my case, here is my directory, and this is my folder name. All right, my folder name. Then here you see this is my result. Can you see that? In my Word file, it is here. But normally, class, we don't copy and pass it directly. You have to rename this variable. All right. From here to use it as, this is an English language learner. So that, you know, your reader understand your variable name. If you report in this variable name, no one understand you. Okay, this is, say, year round. This is mobility. This is average class size. Average class size for K3. This is average class size for K4 to 6. Average class size for K4 to K6. All right. So you have to rename the variable yourself, by yourself. All right. After you rename it, adjust your table into a proper position. You know, do it like this. All right. And also you can add the note as well. Here, there are two numbers. One is coefficient, one is standard error. You can say, all right, standard error in standard error, all right, in the parentheses. All right. So that your reader understand you more. All right. When they look at it, oh, they know this is coefficient. What is the number here? Because some researchers, they report T statistic. Some researchers, they report P value. Some researchers, they report standard error. So it is confusing. You have to tell your audience that the number in the bracket is standard error. Otherwise, they do not know exactly. But normally, if you don't tell them, they will assume that this is standard error. All right. So again, you have to rename your variable and also give extra note on this. All right. And then after that, you can copy this table and pass in your report. Following me? Questions? Question everyone? If you want to be more specific, you can say, okay, average class size here. Then you also give them the unit. What is that? Number of person, number of student. All right. So when you interpret, you say, okay, this is when the number of students, average class size, number of size or number of students of average class size in K3 increased by 1 unit. You mean the number of students increased by 1 unit. What happened to academic performance of the elementary school? All right. Guys, are you following me? Do you have any questions? Normally, when I do it, I don't report constant. It is not important. So I delete it. I mean myself. I delete it. I only keep the variable R and N's right. And then give the captions. What is that? I would say, somewhere like this. I would say table 1, the effects of independent variable in, or if my interest, I would say the effect of English language learner on academic performance. All right. Here it is year 2000. The variable here is in 2000. This is right. You following me? Questions? Interpretations? Reporting? Can you follow me? Right. Let me call the group to clarify. Wait a minute. All right. So this is message here. All right. Class, group 1. Any question from group 1? You following me?
Yes, sir, follow.
All right, group 2. Any member from group 2? Can you follow me?
Yes, sir.
All right. At least I have one. Group 3?
Yes, lecturer.
All right. We have Kim Hua. Group 4?
Yes, like yes.
All right, Muni. Group 5?
Yes, lecturer. I'm
All
following
right.
you.
We have Vichet. Group 6? Questions? Are you following me?
Follow, sir. Follow, sir.
All right. All right. We have Uttam. The last group, group 7. Questions? Following me?
Yes, teacher, group the van, right?
All right. All right. All right. Shirley. All right. At least one of you guys, I have at least one of your member, a member asked me some question. All right, guys. That is about reporting and interpreting multiple linear regression. As I said, please spend more time reading the text to understand more. What I explain you, what I tell you is the main point. If you follow me, I believe that if you read some regression or some paper that do regression analysis, from now on, you should have a better understanding. You should understand it for now. All right. Not all, because here you just only learn the basic model, only the basic model that use cross-sectional data, both independent and dependent variable are numerical or continuous. All right, class. What I want to do next is I want to give you some example of multicollinearity and how we detect multicollinearity and perfect collinearity. If you remember, perfect collinearity, all right, perfect collinearity is third assumption in multilinear regression. What do you remember perfect collinearity? Exact relationship between two independent variables. And how you check it? You have to check what we call VII, variant inflationary factor. In Stata class, right? In Stata, to check multicollinearity using VIF, you have to first run regressions like this. I run regressions, all right? And then I just quickly run VIF after regressions. This is variant inflation factor. Then here, we obtain VIF. If you remember, I don't know if you remember, let me get back to the slide. It was on slide week 7 or week 8. We are now on week 8. Week 7, no, we are now on week 8, right? Let me scroll up. Not here on week 7. We discussed this on week 7. All right. Variant inflations. That's that. Wait a minute. Let me go back to not here, not here. Where is it? Here.
Teacher.
Yep.
Teacher, today do we have a group presentation?
If we have time, yes. Let me finish this first, and then I think we may have one group presentation.
Yes, sir. Thank you, sir.
All right. Here, to detect perfect collinearity, class, we have to look at variant inflation factor. If variant inflation factor is higher than 10 from our lecture note, there is a multicollinearity. Sorry, this is multicollinearity. I'm sorry, class. I am confusing you. What we are discussing now is multicollinearity, not perfect. All right, multicollinearity. Multicollinearity. If there is a multicollinearity, standard error is large. All right. So to detect multicollinearity, you run regression VII. And as from the lecture, if the VIS is higher than 10, there is a multicollinearity. Here, after you run VIF, you see that the highest score is 6.11, below 10. Then there is no multicollinearity in your regression. What if there is a multicollinearity? We discussed if we found that there is a multicollinearity, you have to explore. You have to drop one variable or the variable that are highly correlated out of your model. All right. In here, we found no multicollinearity issue in our regression. All right. Hopefully, you still remember what do we mean by multicollinearity. Following me. All right. To detect it, run regression. Shortly after this, run VII. And then you obtain this. Look at the value VII here. If it is lower than 10, no multicollinearity. All right. If there is some variable that higher than 10, you may need to decide drop one or two variable out of the model and run regression and check VIF again. But remember, class, if you have large number of sample, in here we have around almost 400. That is why multicollinearity is not the issue. All right. Some people, to check multicollinearity, they run correlation. You run correlation among independent variables. For instance, you run correlate. This is you only include independent variable. And remember the score of independent variable from -1 to 1. Here, the highest one is between mil and L. And this is only 0.7. If you want to check one by one, you have to run correlation. Questions? Right? Questions? Following me? Guys, if you have large sample size, don't worry about multicollinearity. But if you have small sample size, you have to check. You have to detect it. All right? Why? Because if there is a multicollinearity, you will obtain large standard error. If you obtain large standard error as the result, you have low t statistic, you have high p value. That is why the variable is insignificant. So you have to detect and make sure that there is no multicollinearity. Any questions? No. All right. Since there's no one asking, I assume there's no question. And now I want to have one group presentation. From last week, we will have group 2, right? So group 2 that has
not yet.
Yep.
Group 2. Yeah, sure.
Really?
We haven't presented.
Right. So let me invite group 2 because group 2 should be the next group because last week we have group 6. So group 2, please, Spence, floor is yours to present your group on your selected paper. I will answer to the. Oh, okay. Group 4 next week. Go ahead, group 2.
Good evening, teachers and everyone. We are from group 2, and now we responsible for the presentations of the research paper that's volunteering improve the employees' ability. So next slide, please, Lina. Lina, next slide, please.
Give me a second.
Here is our content of the presentation. First is the introduction part, and in this part we divide into four small points: the background of the study, research problem, research objective, significance of the study. In the methodology part, we have the British House Panel Survey and the panel analysis of the British Household Panel Survey. And the last one is the result and discussion. So next slide, please. Liên An, let me share the slide. Liên An. Okay. So here is first in the introduction part, we go to the background of the study. So the background of this research paper, we focus on two main points. First one is the interest in employability and the volunteering fit. So the interest of the interest in the employability is the it was researched by Hillett and Pollard that addressed the term of the employability by stating that the employability is impacted by three main factors that such as the individual, the personal circumstance, and also the external factors. And regarding this regarding this point, the employability, we can define that it is the ability to ability not only to get a job, but also it retains them as well. And whilst the volunteering is a supporting factors that have to retain the employability. So let's move on. Let's move to the next slide, please. And here is the second point, the volunteering fit. So it describe the definition of the volunteering, which are unpaid activity that are conducted to the benefits of the people. For instance, we in the research paper, it provides the examples in the UK country which employs the people, which employ people are more involved with the volunteering due to the desires to learn about the new skill and also the aim to getting with the job. And however, despite some of this positive connection, there is also the conclude or that state that there is no direct relation between volunteering and employability. So next slide, please. So let's move to the research problem. And so the problem of this research is the unemployment rate in the UK country. So in the UK, we notable that from day to day, the people start to volunteer because they think that participating in the volunteering provide them as the opportunity to get a job, and also provide them a chance to develop a new skill, and also to build a network, build a also to try a vocation and gain more experience. Next slide, please. So here's to the research objective. So in this paper, in this research paper, it's provide a support to find a support arguments for how volunteering have improve the employee's ability and acts as the role employment. Next slide, please. So, and this is the last point of the action pack, which is the significance of the study. And in this pack, with that only a few researchers were conducted on the relationship between the volunteering and the employability, whilst many studies failed to establish a direct link between them due to the difficulty of finding the statistical evidence. And so this paper is to fill in order to fill the gap by using the longitude data from the British household panels in order to test the effects of the volunteering to employment ability outcome. So for the introduction to the methodologies part, which presented by Ling An.
So we now move on to the methodology part. The study using the British Household Panel Survey study, BHPS, which is the long-running panel study. It is in the form of longitudinal that conducted for over 18 years period from 1991 to 2009 in the UK. The question of the survey are mainly related to the study, the standard human capital, the demographic variables such as education, occupation, age and gender, as well as the earning hour and the times they do the unpaid volunteers. As the result of the survey, we found out that 23% of people did the unpaid voluntary work, while 27% of people participate in the local groups. And we also found out that women are more likely to do the volunteer work than men. So let's move on to the next part, will be presented by the next team member.
So yes, moving on to the second point of the methodology, which is about the panel analysis of the BHPS, the British Household Panel Survey. So in this paper, they ran a series of regression model to determine the relationship between volunteering and the employability. And of course, in this paper, it also separate the model of the employability into three categories, which namely moving into work, remaining in work, and the earning levels. And each model or each category was controlled by the education and also a widening of social economic characteristics such as age, gender, and so on and so forth here. And in order to examine the effects of volunteering on entering the employability, the paper also carried out a series of logic regression model, which you can see in the slide. And I'm not really sure how to explain this two equation where it come from, but because the paper itself just show us this two equation, so not quite sure how it really means. So yes, but it just show us that in order to examine the effect of volunteer ring that can enter into their employability, they use this kind of regression model. And furthermore, for the wage rate, the paper also using the OLS to examine the standard wage, which they come up with this kind of equation, and also have include many variables such as gender, age, job sector, education, and so on and so forth here. So yes, I think that pretty much for this analysis. And moving on to the next team member.
So here comes the result and discussion. Next slide, please. Okay, so in this paper, it showed that volunteering on a monthly basis has a positive effect on the chance on the chances of people who are not in work 1 year and moving into paid employment the next year. However, those volunteering on a weekly basis or yearly basis have an opposite effect. And for like age, the people age around 45 to 60 when undertaking a monthly or slightly less frequent volunteer basis had a positive effect on the chances of moving into employment, whereas people age between 26 to 44 volunteering has very little effect, either positive or negative, on the chances of moving into employment. So as for ages between 16 to 25, it had no positive effect no matter how much they volunteer. So it is also seen that volunteering several times a year had a significant but a little bit positive effect on job retention, whereas more or less frequent had no effect. And moreover, the effect of volunteering on wage rates as an indicator of labor market progression show that volunteering has a negative effect on wage level. And wait, oh, and wait, okay, and oh my god, wait, please. And volunteering does not help people get, and moreover, volunteering does not help people get in on their career in terms of earning more. However, volunteering does help build up an individual skills, confidence, work practices, and social contacts, but it does little to address any limits within the demand side of the labor market. Furthermore, volunteering may serve as an alternative tool or in addition to work, because it can also be regarded as leisure, service, or caring activity. In overall, volunteering does not have a strong or negative effect on employability outcomes. Yet volunteering can improve an individual's skills, confidence, and self-esteem, as well as help build their curriculum vital and context, but it is unlikely to affect the demand side of labor market. So any employability gains are limited based on their the individuals themselves. And that is the end of this part, and move to the next slide. There's the data about the paper. Yes. And you guys can look at it.
It's too small. It's okay. It's okay. All right. All right. Thank you, group 2. Leave it here. Leave it here. Just enlarge it. Just enlarge it. All right. Leave the slide here and just enlarge it so that I can connect this slide to some presentation. All right. Just one. All right. Good. 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 All right. So, guys, thank you, group 2. Even though it is, you do not fully understand it when you're reading, but I hope today you can learn it more. If you look at this table for now, you see that the table is the way that I teach you how to extract standard table earlier. Remember? So basically they have coefficient, they have standard error, and they have star. You see? It's the standard way that I just taught you how to extract the table. And you see, each column presents one regression result. Okay? So normally good paper do like this. And I would say the paper that you have read is good. One point is that they use a very solid data. Guys, you look at this nature of the research. My apology, class, we're gonna be 1 or 2 minutes over today. Okay, my apology. So because the researcher want to look at the relationship between volunteer and employability. If they want to look at volunteer and employability, guys, you cannot use cross-section data. Why? Because if you use cross-sectional data, you're gonna ask, are you working now? Are you volunteer? That does not make sense. You can only see the relationship between volunteer and employability if you ask them, are you volunteer right now? If they say, if no, I am not volunteer, I am not working. So you only ask those who are not working for now, and next year you ask them again. That is why this paper use panel along the longitudinal data, because they have the data from the past, whether they are volunteer or not volunteer, and then they have the data on employment in the next year, right? So that they can connect the data. So what here, the author use two models. One they call logic, one they call OLS. And OLS is what you understand. Weight equation, right? Weight equation here. They found that, you know, volunteer does not have positive effect on weight. That understood more. Normally, if you guys are the student who volunteer, meaning that you have no experience. So if you join the labor market, you earn less than the other who have, you know, more experience than you. That is why this volunteer people or sample earn lower weight than those who do not volunteer. Why? Because they have more experience. Probably that is the case. But what they found here with logic, why logic? Because dependent variable they have is employability. 1 yes, 0 no. So their dependent variable for employability is not quantitative. It's not quantitative. So it is dummy. It is categorical variable. So they cannot use OLS. They cannot use multiple linear regression. Next week class, we will discuss regression with qualitative information. But I only take you linear probability. But what the presenter just presented right now, logic model, it's just what we call non-linear probability model. What we cover this course only linear. You remember when I discussed about multi-regression analysis? One of assumption is linear in parameter. But when they discuss in the logic here, they use non-linear model. All right. So I believe that even though you guys do not fully understand the paper, but you guys follow the whole way of the process, and you can adopt that in your research or your group assignment, from introduction to significant to objective to method to data to analysis. Here, because you cannot understand the logic model, but the difference is only their dependent variable is 0, 1, qualitative information. You will learn more next week. All right. Thank you, group 2. I stop here. And I see someone's drop a message. Let me have a look. Thank you, group 2. You can close the window. Group 4. Lecture, when will we get to know how to get data set for? Guys, that's what I want to say, and we want to discuss next week. For data set, you know, for data set, I would say that I do not have a good idea to provide you a good data set. So when you start working and reading the paper, you should identify the data set. Next week, I will provide you a few sources of data set. But again, you need to spend a lot of time to get to know those data set. If that data set can be employed in your paper or not. Again, for instance, group 2 now they are interested in employability and volunteer. If you got to do that with your group assignment, you need to identify data yourself. Next week, I will give you a few sources to open data, to free data, but it may not be relevant to your paper. All right, David, I hope I answer your question. In short, I do not have data that may you know help you to analyze your data, but I only give you some sources of potential data where you can explore more in case it can be interest of you. And that open data source is from the textbook that I upload in our course, such as using data for principle of economics, and they have the data. I will send you the link next week. That is all for today, class. You're gonna have another quiz release this week. Stay safe and take care. I see you next week. Next week we'll have group 4 presentation. Bye bye.
Goodbye, Lek.
Bye everyone.
Goodbye,
Bye everyone.
Thank you, teacher. See you next week.
Goodbye, Lek.
See you next week.